Okay, so this video is about calculating the water of crystallization and knowing exactly how many moles of water are attached to an ionic compound. In other terms, we can also say analysis of a hydrate. So in this video, you will know or understand what is meant by a hydrate. You should be able to identify a hydrate from its formula just by looking at it, to understand what an anhydrous salt is and how does it look like, and know the differences in terms of the chemical formula between a hydrous and an anhydrous salt, and to be able to find the empirical formula for this hydrated crystal. So, for example, this is a past paper question that you could be looking at. So here we have an apparatus where there are barium chloride crystals. Crystals means it is hydrated, and so they're applying heat, and here we have water condensing, meaning that we are dehydrating it. And so some data is given to you with the steps along with the procedure, with the data. And then they ask you a few questions about the experimental procedure, and then you will be finding the value of X, which is how many moles of water are attached. So at the end of this video, you should be able to answer this question. We will go through it. However, let's go through the theory part. So when we say a hydrate, it's basically a compound that has water of crystallization inside it as it cooled down while it had some water bonded to it. So this basically means here that you will have an anhydrous salt with X moles of water attached to it, so bonded to it. So they come in the ratio of 1 to X. Now, X could be any number, any whole number, 5, 7, these are the numbers that come up, for example. So here, I can show you an example, but when we say it's anhydrous, the anhydrous is the part without the water. So if you look at this formula over here, magnesium sulfate is the anhydrous, whereas over here, magnesium SO4.7H2O is the hydrated salt. So this is anhydrous without water, and then whenever I add the 0.7H2O, it becomes hydrated. Now here we see that water molecules, there are 7 water molecules bonded to 1 mole of magnesium sulfate in the ratio of 1 to 7. So again, what we want to do is we want to get to that mole ratio. So we want to see to how much it will reduce. Now in the lab, experimentally, you will be given masses only, and so you have to deal with these masses in order to convert them to moles. So this is an experimental setup where they conducted the experiment, and then in a crucible where the crucible and the lid mass was recorded, and then the crucible lid and then the hydrate, basically before it lost the water as a crystal form, the mass was recorded as this, and then they found the mass of the hydrate by subtracting these two values. Now the mass of the anhydrous salt is found after heating the apparatus. So after, for example, over here, after you heat it, whatever mass remains in the apparatus is the mass of the anhydrous one without the water of crystallization. So that's where they got their data from. So basically, and so that anhydrous salt is found by, sometimes you may need to do some subtractions over here if it's inside the crucible or whatsoever. But let's see how it was done here. So the mass of the hydrate basically is the crucible with the lid with the hydrate minus that of the crucible and the lid. So these are the two values. And then you should show your work. For the second part, to get the anhydrous, you need the mass of the water as well. Therefore, you have to subtract the mass. You need to find the mass of the water. So basically, you're going to take the mass of the hydrate, which had the water in it, minus the mass of the anhydrous, which was eventually found, okay, without the crucible. Okay, so then you get the mass of the water. So it's very important to be able to read the data in order to do your calculations. Why are we doing this? Because eventually you want a ratio between the water and the magnesium sulfate. So What happens over here is that you're going to have a relationship between the magnesium sulfate and the water of crystallization. So you need to find this value X. So first, you need to find the mass of the magnesium sulfate on its own as anhydrous, and you need to find the mass of water on its own. And so once you get the mass by subtracting over here, once you get the mass of the magnesium sulfate on its own, and then the mass of the water on its own by doing these subtractions over here, you can now convert these masses in grams into moles by dividing by the MR of each one of them, or the molar mass or the formula mass. So you're going to divide by the MR of magnesium sulfate, which is 120, if you add them together. And then here you will divide by the molar mass of water, which is 18 because it's 16 plus 2. And here it's just adding up that of magnesium, which is 24, and sulfur, which is 32, and 4 oxygens, which is 4 times 16. And that's where you get the 120. Now, calculating this value for magnesium sulfate gives you 0.0075 0 moles of magnesium sulfate, and for water you are going to get 0.0509. Now you need to simplify again for the simplest ratio, so you're going to simplify by dividing by the smallest value here, and then you are, which is 0.00750. So this will give you a ratio of 1 to 6.79. In this case, you can round up and it becomes a 7. Okay, so it's a ratio of 1 to 7. And in this case, you now have 7 moles of water, 7 moles of water for 1 mole of magnesium sulfate. That is why now your formula is going to be 1 to 7. Now I'm going to show you another example over here. So here, for example, the data that was given to you, the mass of the crucible was recorded, the mass of the crucible with barium chloride crystal, so the hydrated one, is given. The mass of the crucible with the anhydrous, okay, which means it's after heating, it's given. So you're looking for two things, because you want a relationship between barium chloride and the water. So always keep that in mind. What formulae am I working with? So you're looking for the salt without the water formula, and then and here you need the water on its own. Therefore, you need a simplified mole ratio eventually between them. But to start, you need to start with their masses. So you need the mass of the barium chloride, which means the anhydrous. The anhydrous is this one with the crucible. So you need to subtract the crucible. Okay, so you can pause the video and work that out in your mind. So then it's 32 minus 30, and that's your mass. Don't round or do anything here. Keep it as it is for significant figures. And then for the mass of water, you need to get the water out of the hydrated one, which is this one, right? Okay, so you're going to have to take the total mass over here, and you're going to have to subtract the mass of the anhydrous out of it. So this will leave the water by itself with the crucible, obviously. So this now means that you have barium chloride mass, okay, for water mass. Now you're going to convert now this mass, which is in grams, to moles. And how do we convert mass to moles? You're going to divide by the MR. So for barium chloride, the total MR is 2008, and the total MR for water is 18. Now you get your moles like this. You need to make it the simplest ratio, so you will divide by the smallest value, which is 0.01. So you get to the ratio of 1 to 2, meaning that this X or N value here before the water is 2. And that's how it's done. Okay, now let's go back to this question, this past paper question, where you've had your, it says record the mass when it's empty, and this is basically, if you look at the data, this is basically the mass when it is empty, 10, and then the mass of the, so you place it, and then you allow it to cool, you heat it, you allow it to cool, and so you dehydrate it, in other words, and then when it cools down, you measure its mass. The mass before heating is this, because here it says BaCl2. Sorry, this says BaCl2 dot XH2O, which means this is dehydrated, right? It's hydrated with tube. And then here, the final mass basically is when it's anhydrous, okay? And so you have to, and it has the tube in it. So you need to do a subtraction in order to get the water on its own. Question, give a reason why he repeats steps 3 and 4 until the mass is constant. Why do we do that? Because we need to make sure that all the water has been removed, okay? Is given off or removed or evaporated, okay? So to make sure that the reaction, that I dehydrated it completely. Now calculate the mass of barium chloride that forms in tube A. So basically a subtraction. Then you need to subtract two values, which is basically 15.75 minus the mass of the tube on its own. Okay, so for you here, it's yeah, you need to subtract these two masses of the tube with barium chloride minus that of the tube. So that would be 15.75 minus 10.55, all in grams. Calculate the mass of water lost. So to get the mass of the water remaining, you need to subtract these two values, because that's the hydrated minus the anhydrous. So that would be now 16.65 minus 15.75 grams, and that will give you the mass of the water. Now determine the value of X. So these masses should be, just give me a second here. These masses should be 5.2 and 0.9. Okay, so that's over here 5.2 grams, and then here 0.9. Okay. Now you need to find the value of X. So you will write over here barium chloride to H2O, and you've got your masses now. You're subtracted, and now barium chloride is 5.2 grams. And for water, we found it as 0.9. That's one mistake that students make. They don't copy the numbers according to the right formulae. So just make sure that it's matching. Okay, you don't need to write grams here if you already wrote it, but just to keep it, guiding for mass. Now we need to get the moles. Now moles is mass over MR, because we need a simplified ratio. So divided by the MR of barium chloride. Here the question gave us that the MR is 208, so gram per mole. And then for H2O, the MR is 18 grams per mole. It's also given, and we should remember it by now. Now you divide, and then you get your your values in order to get your simplified ratio. So that is now 0.025 moles, and for this one, it's 0.9 divided by 18, which is 0.05 moles. Now I have a mole ratio. However, I need a simplified mole ratio, so I'll need to divide by the smallest value. So that would be 1, 2, 2. Okay. Now, this means that they are in the ratio of 1 to 2, which means for every barium chloride molecule, I have 2 molecules of H2O, and that is the empirical formula, or the formula for this hydrated compound. Okay, so I hope this was helpful. And that's really what you need to learn about the hydrate. One question could be sometimes some of the things that they might ask about, like, for example, in reality, the value was different than the value that was calculated. So you want to talk about what could have gone wrong in this experiment. So for example, not enough heating was done, so the value of the moles changed. Okay, so it wasn't heated until the reaction was, sorry, until it was completely dehydrated. This is not a chemical reaction. This is more of a physical process. So you would say some water is still retained, and therefore the value of the mass changed higher than usual here. And this will impact the number of moles towards the end. Okay, I hope this was helpful. Thanks so much for your time.